Hi, in this tutorial we are going to solve a question related to naming of carboxylic acids and its derivatives. We have 5 molecules to name and we have to follow IUPAC rules. Okay, let's start from the first molecule. Let's start naming from the first molecule. Okay, in the first molecule we have a cyclohexane ring, and outside of ring we have two carboxylic acid functionalities. So basically this is a cyclic carboxylic acid, and also we have to follow either cis-trans or RS rules because we have a 3D drawing here. Okay, so for carboxylic acids, if we have carboxylic acid functionalities next to the ring, the name is a little bit different from the like open chain carboxylic acid. So basically the name of this molecule will be cyclohexane carboxylic acid, but we have two carboxylic acids, so it's going to be cyclohexane dicarboxylic acid. But we have to number the location of the carboxylic acid. So let's start numbering from here. This is number 1, this is number 2, and number 3, and we don't have any other substituent. So this is 1,3 dicarboxylic acid. So let's write the name first. This is going to be cyclohexane dicarboxylic acid. And also we have to specify the location 1,3, so we can follow the old naming system, IUPAC old naming system. So we can place the numbers before the parent name. So this is going to be 1, 3 and dash cyclohexane dicarboxylic acid. But as we said before, here we have a 3D drawing, and if we look at this one, carboxylic acid functionalities are on the same side of the ring, so we have to say that they are on the same side. But it can be this, we cannot say cis, because if the carboxylic acid functionalities are going inside the paper plane, if they are drawn as wedge bonds or dash bonds, sorry, it's going to be again still cis. So here we have to use RS designation, R or S configuration. So how are we going to do it? So let's just draw again here carboxylic acid, then let's number, then we can decide which one is R and which one is S. So let's draw again. Doesn't have to be perfect, but just we are naming now. So this is carboxylic acid, this is hydrogen, and this is carboxylic acid, this is hydrogen. Let's use different colors. Let's use a red marker for numbers. So let's start from this side, and let's mark the chiral carbon. So this is the chiral carbon. We are putting here an asterisk, and we know that carbon with 2 oxygen has to be number 1, and this carbon should be number 2 because it's next to another carbon with carboxylic acid. This carbon has to be number 3, and hydrogen has to be number 4. Number 4 is receding towards back, or it's going inside the paper plane. So if we look at 1, 2, 3 rotation, 1, 2, 3, so let's just place arrows 1, 2, 3. So it's clockwise rotation. So this carbon should have R configuration. And how about this carbon? We can try with a blue marker again. So this again chiral carbon I'm marking with an asterisk. Carboxylate carboxylic acid should be number 1. This same carbon should be number 2. This carbon should be number 3, and hydrogen has to be number 4. 1, 2, 3. So let's just use arrows, so it's counterclockwise hydrogen going inside the paper plane, so this has to be S. But without doing this, basically we can also say conclude directly S, because if you look at this molecule, it has a symmetry plane, and like this part is reflection of that part. If this is R, this has to be S. So basically it is going to be like we start numbering from here, 1S 3R. So we have to place here another thing. So 1S comma 3R close the parenthesis dash 13 cyclohexane dicarboxylic acids. But if you start numbering from here, again it's going to be 1R3S. So basically this molecule is a meso compound, if you look at very carefully. But let's just place here 1S3R. Okay, let's move to second question. In the second question, again we have a carboxylic acid, and this carboxylic acid is an open chain carboxylic acid, and let's number how many carbons we have. I'm going to use red marker, so this is number 1, number 2, number 3, 4 and 5. We have 5 carbon, so let's write 5 is its corresponding alkane. Alkane name is pentane, so let's write pentane. But this is a carboxylic acid. In carboxylic acids, what we were doing, we were dropping the terminal E at the end, and we were adding oic acid if it is an open chain carboxylic acid, pentanoic acid. But if you look at here in the structure, we have an alkene functionality, so instead of pentane we have to say pentene. So let's just write again. So this is pentenoic acid, and carboxylic acids, oic acid position, or this has to be always number 1, so you don't have to say one oic acid or one carboxylic acid. But since alkene is at the third position, we have to say either here 3 pentanoic acid, this is the old naming system, or we can do this way, pent 3 in oic acid. In some places people prefer this way, pent 3 in 1 oic acid, but as I said before, this one is not necessary, because we know that always a carboxylic acid carbon has to be number 1. Okay, let's keep this one or this one, we can do both. You know that if you have an alkene functionality, carbon-carbon double bond, we have to always check whether it is cis or trans or E or Z. Okay, if you look at here, we have a substituent here, and there is a hydrogen, and there's another hydrogen but another substituent. So this is disubstituted alkene. Disubstituted alkenes can be either cis or trans. If you look at methyl and this substituent are on the opposite side, so this has to be trans. So let's write here trans or trans. So basically both naming are correct, trans pent 3 enoic acid or trans pent 3 in 1 oic acid. Okay, let's move to next molecule. Let's look at next molecule. Next molecule is a carboxylic acid derivative, and instead of OH we have here a halide, so this is an acid halide. So let's write here what is this molecule. This is an acid halide or acid chloride. So let's write here acid chloride. Okay, how do we name this molecule? Basically you can start naming as a carboxylic acid, but let's number how many carbon we have. We have 1 in the longest chain, starting from the carbonyl carbon, 1, 2, 3, 4 and 5. So this is 5-pentane. The corresponding alkane name is pentane. If it were a carboxylic acid, how are we going to name it? So let's treat that this Cl chlorine is OH, so it's a carboxylic acid. So let's just write the name. So we have at third position, third carbon, methyl methyl dimethyl at fourth methyl. So we have 3 methyl groups. So how are we going to report them? So basically we have to write their positions. We have 3 and 4. We have to say trimethyl. And if it were a carboxylic acid, if we assume it's a carboxylic acid, it's going to be pentane, but it's not an alkane, right? So we have to say it's a carboxylic acid, oic acid. But as you know, this is not a carboxylic acid. This is an acid chloride. So what is the rule? So basically, oic acid will be replaced by oil chloride. If it were a bromide, oil bromide. So let's just go back. Instead of oic acid, we have to say it's oil chloride. So again, like we reported the location of substituents, we treat it as a carboxylic acid. We named as a carboxylic acid, and we replaced oic acid as oil chloride. Okay, let's move to the next molecule. If you look at next molecule, it's again a carboxylic acid derivative, and here we have an alkyl group with 2 carbon after oxygen. So let's write what is this molecule. This molecule is an ester. Okay, so how are we going to name this molecule? In esters, we have to say this, the name of alkyl groups, ethyl, then this part. But let's treat again this one is a carboxylic acid, then we can convert it to ester naming. Okay, let's look at here. How many carbon in the longest chain in this part? Not in this part, so because this part will be named differently. So we have 1, 2, 3, 4, 5, 6. So we have 6. If it were a carboxylic acid, if we assume that this ethyl group is just a hydrogen, so it has to be a carboxylic acid name, and let's name according to that. Accordingly. Okay, so it has to be hexane, but it's not hexane, E will drop. We will say hexanoic acid. And let's start with the name of this alkyl part here. What is this? It's ethyl. So basically from hexanoic acid we will go to another naming, which is going to be ester naming. But for esters you have to start with the alkyl group after oxygen. So it has to be ethyl. We start with capital letter. There will be a space. It's going to be hexanoic acid. So in esters, ic acid will be replaced by 8. So let me just circle this part. It has to be replaced by 8 suffix. So ethyl hexane O8. So basically we have to start with the alkyl group after oxygen, then this part as a carboxylic acid, and ic acid has to be replaced by 8 suffix, so it's going to be ethyl hexanoate. Okay, let's move to the last option. In the last option we have here a carboxylic acid derivatives. Here we have a nitrogen instead of oxygen, and also it has a substituent, methyl substituent. So basically this is an amide, so we have to recognize it's an amide. So again, let's treat this one as a carboxylic acid. So this NHCH3 part, let's assume that it's OH. How are we going to name it? So basically we have to treat as a carboxylic acid. So we have 1, 2, 3 carbons in the longest chain. So this is going to be propane, but E will drop and we have to add oic acid. So this is propanoic acid, if it were a carboxylic acid, but it is not a carboxylic acid, it's derivative, so it's amide. So what's the rule? So again, oic acid part has to be replaced with amide suffix. So it's going to be, I'm writing here, it has to be propane amide. Okay, but this name will be correct if this methyl was hydrogen. So if this part was NH2, so we have to say that there is also a methyl substituent on nitrogen. So you can think that nitrogen is like, instead of like nitrogen, you can assume that it's a carbon and it's number 1. So if you say N, there is something on nitrogen, like as a number, after number we were always using dash, N, and what is the substituent? Methyl. So N methyl propanamide. Let's write here a bit properly. So N as a number, or the location of whatever the substituent, and with capital letter, the N-methyl propanamide. Okay, so N-methyl propanamide is the official IUPAC name for this amide. So what did we do in this tutorial? In this tutorial, we named carboxylic acids and their derivatives following IUPAC rules. Thank you for watching for this video.